So my dear students, we are going to discuss about digital logic circuits module 5, which is sequence circuits. So far we have studied combinational circuits. So module 4 is combinational circuits, module 5 is, as per your syllabus, module 5 is sequential circuits. So under this, what exactly that we are going to study is, we are going to study flip-flops, of course, various varieties of flip-flops. The basis for flip-flops is latch. So first we will cover latch, then followed by various flip-flops. We try to build latch first. From the latch we are going to build various flip-flops. The various flip-flops that we are going to discuss are SR flip-flop. SR flip-flop stands for set reset flip-flop. D flip-flop. D flip-flop stands for delay flip-flop. T flip-flop. T flip-flop stands for toggle flip-flop. Then of course we have JK flip-flops. From these flip-flops we can build registers, we can build shift registers, we will also build counters. Counters are of two varieties, synchronous and asynchronous. Synchronous, asynchronous are two varieties of sequential circuits. Sequential circuits can be of synchronous or it can be of asynchronous. Synchronous will use clock signal, asynchronous no clock signal. No clock signal. We are not going to use any clock. So last we will discuss about ring counter and Johnson counter, but they are not the least. Then let's look at objectives. Objectives will be more clear once we complete this module. So you will be in a position to understand what is sequential, what is combinational, what is flip-flop, how it can store one bit, either maybe 1 or 0, how we can do the design of shift register or normal register, or it may be a counter. Okay, this will be very clear once you complete this sequence circuits topics. What is exactly sequence circuit logic look like? It will be having memory. Okay, how this memory will going to impact the current state, okay, that we will try to explore. We will also look into how exactly a sequential circuit look like. Okay, so because we have memory elements in a sequential circuit, it is going to remember the past inputs. So at any instant of time, the output not only depends on the current input but also depends on state of the memory elements. That means what is there in the memory is going to impact. That I can show with the help of a diagram here. So there is a input. That input is being applied to combinational circuit. We are getting an output. Okay, there is a memory element. Whatever we are giving to the memory element is next state, and what exactly we are getting from the memory element is current state. Now if you want to know the current state, this current state, which is function of past inputs, previously what you applied the inputs, previously applied inputs, and the initial state. Initial state means initially what is there in this memory is going to decide current state. Are you getting? Previous inputs, current initial state will give you current state. Okay, so there is a combinational circuit. We are getting output. Output may be coming from combinational circuit or combinations of this. So we may take it from memory elements and combinations together as an output, or from combinational circuits only, or from memory elements only, or from the both. Okay, so we can take output in any manner because it is a general block diagram, just block diagram. It is showing, okay, how exactly a sequential circuit look like. Okay, anyhow we will see this in detail. Okay, then what exactly the varieties of sequential circuits? Just now I told you sequential circuits are of two varieties, synchronous and asynchronous. So synchronous and asynchronous. Synchronous sequential circuits, asynchronous sequential circuits. In sequential there will be synchronous, there will be a clock. I told clock, how exactly clock will be? Clock will look like this. What exactly is this? Is it is 0, 0, then 1, 0. It is combinations of 0. Here it is 0, it is 1. Here it is 0, it is 1. Here it is 0, it is 1. Okay. Here it is 0, it is 1. Likewise. Okay. So this clock gives the timing information. Okay. This is used for synchronization. So clocks used in sequence circuits is synchronous sequential circuits. If there is no clock, asynchronous. Okay. So in asynchronous you won't find any clock. In asynchronous, memory elements works as a delay elements. Okay. So in asynchronous circuit, output depends on exactly the input signals at that instant and the order in which the inputs are changing. Okay. The inputs that is being applied and order in which the inputs are going to change decides the output in synchronous. In case of asynchronous sequential circuits, in synchronous sequential circuits, based on the clock, how clock will be? Clock will be like this. So clock may be level triggered, clock may be edge triggered. Level triggered means for any level 0 or level 1 it is going to change its state, or it may going to change an edge 0 to 1 transition or 1 to 0 transition. This is 1, this is 0. These are called edge transitions. These are called level transitions, going from 0 level to 1 level, level 1 to level 0. So this is level, this is one level, this is another level, level 0, level 1. Transition from 0 to 1, transition from 1 to 0. This is what exactly for synchronous sequential circuits. Okay. So these synchronous sequential circuits are also known as clocked sequential circuits. So if it is a clocked, there will be a clock here, of course, right? Rest all same. So we will look into clocked sequential circuits, how exactly they are going to work. Just we have discussed it already. Based on the low to high or high to low clock, we call it as clock edge. Okay. So when clock maintains its value, that means when there is no change in the clock, the flip flop outputs are not going to change. Okay. So we will discuss once we build the flip flop, this will be more clear. So we are going to deal with latches. Latch is a 1-bit memory cell. Its operation is not based on the clock. It is an asynchronous memory device which can store 1 or 0. So we are not going to use, or in case of synchronous sequence circuits we are going to use clocks. So we will build the flip flop with help of latches. So basis for all the flip flops is latch. So we will start with flip flops. To start with flip flops we should know latch. So we will start with latch.